Okay, you're right. So in this video we're going to have a look at arc lengths and distances involving parts of a circle. So before we've done circumference where we have a full circle, but arc length is what we use when we have a curved edge that's part of the edge of a circle. So let's have a look at a circle just to be clear what we're talking about here. So the circumference is the distance around the edge of the circle, so the perimeter of a circle. So it's how far would it be if we started here and walked all the way around the edge and came back to the same point. Now an arc length is where we just take part of that. So an arc length is a curved distance, so something like this curved distance in green here. And where we get that length, where we're concerned about that length, is where we have shapes like this shape in green that are just part of a circle. And so when we talk about arc length, we're talking about that curved distance on the edge of the circle there. So let's have a look at an example where we're going to need to find an arc length to answer the question. So if a circle has a diameter of 8 centimeters, find the length of the curved part of the semicircle and the perimeter of the semicircle. So let's draw this to see if we can figure out what's going on. So if we have a circle, the semicircle will just be either the top half or the bottom half, or any half of the circle. So I'm just going to cut it in half so that we can see the top half here. And so that would be my diameter there in black. And I'm going to do the curved part in green. So we can clearly see that if that's a semicircle, it's made up of a curved part and the rest of the circle. So if that's our semicircle there, we're told that it has a diameter, this distance here, of, and we're told D equals 8 centimeters. So we're going to write D equals 8. So to find the curved length, that's that green length there, what we want to think is that's part of the circumference, and that length is just going to depend on what fraction of the circle have we've got. So whatever fraction of the circle we have here, this arc length will be the same fraction of the circumference. So let's start by finding the circumference. So we know that C is going to be equal to pi d, and we can substitute in our value of d. We know that d is 8, so we're going to substitute that in there. So our circumference is just going to be 8 pi. So let's move that up and let's show that we've got our circumference equal to 8 pi. So that's an exact amount, which is really good to keep using as long as we can. Now the important thing here is to find that green length, which I'm going to call L. That green length depends on how much of the circle we have. So a semicircle is half of the full circle. So this arc length around the outside, this L, is just going to be equal to a half of the circumference. Or we could write that as C over 2. So we just need to divide the circumference by 2, and that will tell us what that curved length is. So all we need to do to find our arc length is we know that C equals 8 pi, and so we can write therefore, those 3 dots for therefore, L is going to be equal to 8 pi divided by 2 over 2, which will be equal to 4 pi. So that is that curved length there. So that's an exact amount, which is a really good way to leave your answer unless you're told to do an approximation. So we're just going to leave that in exact form for the moment. Now if we come back up to our diagram for a moment, let's have a look here. So we found that green length, but the question also asks us for the perimeter of the semicircle. Now the perimeter would be this green length plus this black length, that black length d, we need to add the length of the straight side as well. So that's the total distance around the edge. So all we have to do to find the perimeter is we can see that the perimeter is going to be equal to that arc length plus the diameter. So we can write that P for perimeter is equal to L plus D. And so that's going to be equal to, we know L is equal to 4 pi and we know that D is equal to 8. So that would be our exact expression for the perimeter. And if we wanted to use an approximation, or the question asked, we could use our calculator to do an approximation for that. But we're just going to leave it exact here because we haven't been told to do an approximation. So that would be the perimeter and the arc length of that semicircle. So the important thing to see here is that because we had half of a circle with a semicircle, we had half of the circumference for the arc length. Now in general, what that means is if we have a particular fraction of a full circle, our arc length will be that fraction of the circumference. So we can write that generally our arc length will be equal to C, the circumference, multiplied by, now when we write this, we write theta out of 360. Now what that means, we see how that's a fraction. So that means that whatever angle we have at the center of our part of the circle, we divide that by 360, and that tells us how much of the circle we have. If we have a full circle, that's 360 degrees, so it would be 360 out of 360. If you have a semicircle, the angle at the center will be 180, so it would be 180 out of 360, which is the same as a half. So that theta is whatever angle you have at the center when you're dealing with part of a circle. So let's have a look at an example to see when we have an angle and how to use that to find the arc length and perimeter of a shape with part of a circle. So here we're asked to find the perimeter of the sector that is shown in the diagram. So noting that sector just means it's part of a circle, so it always looks like that pizza slice kind of shape there, and it's got 2 radii on either side there and a little arc length there. So what we'll point out there is that this is made up of a curved length here, that's that arc length around the outside in green, so I'm going to call that L. And we're also given, see how these are marked equal lengths here, these 2 straight lines here, those are marked equal, so they're both 6. And because it's a sector, we know that that's the radius of our circle. So we're going to write down that R is equal to 6, so 6 centimeters there. Now if R equals 6, we know that D is going to be equal to double that, so D will be 12. So we can just do that there. D is going to be equal to 12. So to figure out our arc length, all we have to do is use our normal relationship here, C equals pi D, and use the value of our D for 12 to figure that out. So we know that C is going to be equal to pi times 12. We can substitute that in, replace our D with 12, and we see that our circumference is going to be equal to 12 pi. So if we write that out, that's our circumference is 12 pi. So to figure out our arc length now, all we have to do is see what fraction of the circle we have. So to do that, we're going to use our angle. We're going to use the fact that the angle at the center there, we're shown that it's 60 degrees. So now to find our arc length, all we have to do there, I'm going to write it in green because I've labelled the arc length L in green. Now it's going to be that angle divided by 360 times our circumference. So we know it's going to be theta. So theta is that notation for angle. Theta out of 360 times our circumference. So we're going to write times c there, and all we have to do to figure that amount out is we just substitute in our numbers there. So we know that our L is going to be, now our angle is 60, and that's out of 360, and we're multiplying it by 12 pi because that's what our circumference is. Now what we can see here is 60 out of 360, well that's a fraction, and that simplifies to 1 over 6. So we actually just have a sixth of our circle there, which is equal to 1 out of 6 times 12 pi. Now if we think about that, we have a sixth of 12 pi, so 12 over 6, that's going to simplify to 2. So we actually end up with our arc length there is exactly equal to 2 pi. So that would be the exact amount for our arc length. Now all we have to do to find the perimeter, and let's have another look at our diagram to figure that out. All we have to do to find the total perimeter is figure out the total distance. So that would be the arc length there, that distance here, and we've then got to add on the two straight distances. Now they're just both equal to 6, so all we have to do to find our perimeter is we just have to add 6 to our arc length twice. So we can see that because 6 is our radius, it will have 2 of the radius. So all we have to do now to find our perimeter of the sector, it will be equal to L plus 2R, because those straight lines are both equal to the radius, which is 6. So we're going to substitute that in. So it's going to be 2 pi, because that's our L, plus 2, and our radius is 6. Oops. So our radius is 6. So we end up with our perimeter equal to 2 pi plus 12. Now that would be, again, that would be our exact answer. And if the question asks us to do an approximation, then we can use whatever approximation is asked for, or our calculator, to give it as asked for, but we're just going to leave it exact here.